Hi, Sienna. Yeah, no problem. So, rationalizing is when you're trying to get rid of a square root. And there's a couple of techniques that you have to learn. Well, the first thing we've learned is when you multiply a square root by itself, it's essentially the same as a square of a square root. And a square of a square root always cancels itself out. So essentially it just gets rid of the square root. What we also learned from difference of two squares is when you have a square root like this and you want to get rid of the square root of 9, you cannot multiply it by the same thing. Cannot. That ends up being 1 plus 2 times the square root of 9 plus 9. So you only got rid of this one. What you do instead is multiply it by the opposite sign. And we know from practice that this is called a difference of two squares. In other words, it's sort of the same thing, but one's a plus, one's a minus. And it always gets rid of the middle term because it becomes 1 minus the square root of 9 plus the square root of 9. So the middle terms disappear. And then this becomes minus 9, which ends up being minus 8. So when we're rationalizing, the whole point is to get rid of the square root. When we're rationalizing a denominator, we're trying to get rid of the square root at the bottom. So if I have 1 or 2 over square root of 3, I'm going to multiply. I can't just multiply the bottom by square root of 3 because this is no longer the same fraction if I do that. But if I multiply it by this, please note that any number divided by itself is simply 1. Well, if you multiply any fraction by 1, it does not change. Even when we're looking for a common denominator, we're multiplying the bottom and the top by the same thing, or we're cross multiplying. So if I'm going to get rid of this square root of 3, I can't just multiply the bottom by square root of 3. I must also multiply the top by square root of 3 because this is technically 1. And what you get is 2 times the square root of 3. And at the bottom you get 3. Please note we didn't get rid of the square root here. We got it to the numerator. And that's why it's called rationalizing the denominator. It's getting rid of square roots in the denominator. When you rationalize the numerator, let's say you have 2 times square root of 3 up here over 2. If we're rationalizing the numerator, that just means we want to get rid of the square root of 3 there. This ends up, when you multiply these two, it ends up being 3. So 2 times 3 over 2 times square root of 3. And of course, 2 times 3 at the top becomes 6 over 2 square root of 3. 6 is divided by 2, becomes 3 over the square root of 3. Oh yeah, well, that was kind of stupid because the 2's right here. Yeah. Let's just pretend it was over 1. Let's just pretend it was over 1 back here. It becomes 2 times 3 over the square root of 3, which becomes 6 over the square root of 3. So this was rationalizing the numerator because it's no longer got a square root of top, but I had to multiply it by 1. That's the secret you got to remember. So if we look at these, it's the same idea. Notice this one's rationalizing the denominator. So we want to get rid of the square root at the bottom and then simplify, and then simplify. I won't do them all, but I'll give you, maybe the tough ones. These are all easy, the ones I've highlighted. You simply have to get rid of this square root 5. So I'm going to multiply it by square root 5. But I have to multiply the top by square root 5. Square root 5 times square root 5 becomes 5. And up top, it's simply 5 times the square root of 5. This is the simplified format. This is how you would leave it because this is exact. I could always take the square root of 5 and multiply it by 5. And then divide it by, this is going to be simplified actually, yeah. Because, sorry, you can see that these are canceled. And it's simply the square root of 5. So in this case, you would just leave it like that. Now, you could always, the reason you don't take the square root of 5 is because it never ends. and you can never write it down accurately. So this is called the simplified exact answer. And if they wanted the decimal answer, you'd find the decimal result of it, whatever that decimal was. Please note that they will take marks off if you don't spot that the 5s here cancel out. So here we're multiplying by square root of 3 over square root of 3. And up top, you simply get 6 times the square root of 3. And down at the bottom, you get 3. But 3 goes into 6 2 times. So you get 2 times the square root of 3. Please note, only square roots can divide other square roots, and only whole numbers can divide whole numbers. They don't mix. You can't cancel this 3 here. So this is the simplified exact answer. Here's the same idea. You multiply square root of 7. You're going to multiply top and bottom by square root of 7. You get 2 square root of 7 up top and 7 down below. This one you would not simplify because the simplified format would be square root of 7 over 3.5. And generally speaking, we don't want decimals. Unless you multiply square root, so you're going to multiply square root of 5 over square root of 5. You're going to get 4 square root of 5 over 5. And it does not simplify. Sometimes teachers like to see it like this. Depends on your teacher. If he wants the decimal there, that would be 0.8 times square root of 5, but I don't really see the point in that. This instead is still exact, but this is how generally we want it. So let's see if there's any tricky ones in here. No, it's square root of 5. Even when there's a negative here, I'll just do this negative. I'm not going to do them all. There's 2 negatives here. I'll do the 2 negatives. I'll do this negative and that negative. So the thing we want to get rid of is the square root of 2. It doesn't matter. This negative you can just assign to the 6. It's either top or bottom. It's usually always assigned. It's put there, but the easiest thing to do is just assign it to the top number. We're going to multiply top by square root of 2. You're going to multiply bottom by square root of 2. Up top, you get minus 6 times the square root of 2 over 2. But 2 can go into minus 6, so you get minus 3 times square root of 2. This one's the same thing. Simply assign the minus to the 4. Multiply square root of 7 over square root of 7. Up top, you get minus 4 times square root of 7. Down bottom, you get 7. These do not simplify. So those are pretty straightforward. Now they're trying to teach you the difference of 2 squares, of what happens when you multiply 2 things with opposite signs. They're trying to get you used to it so that you understand how to solve problems later on. Well, you quickly learn that square root of 5 times 5, square root of 5 rather, is 5. Square root of 5 times minus 1 is negative square root of 5. 1 times square root of 5 is plus square root of 5. And 1 times minus 1 is minus 1. You're ending up with 5 because these cancel, minus 1, which is 4. That's the simplified answer. Please note that whenever you have 2 brackets that are essentially the same, except that's a minus and that's a plus, know that the middle terms will disappear, and you can just multiply the first term and the last term. There's no point going minus square root of 5 plus square root of 5. Now your teacher might want to see it at this stage, but generally speaking, you don't. So that's 2. That's minus 3 times square root of 2. That's plus 3. Now I think in this stage, your teacher will want to see this work. Notice that these minus 3 square root plus 3 square root cancel. And then finally, plus 3 times minus 3 is minus 9. And 2 minus 9 is minus 7. So that's the final answer. Let's just do the steps without. That's 3. And that, even though it's a minus outside, it still becomes, it's essentially a minus 1. So it's going to be minus 1 times the plus 1 up here. It's going to be minus 5. Because the square root of 5 times the square root of 5. Minus 2. The middle terms in this case would be, you're allowed to multiply things inside. So if we're going to do the middle terms in this case, it's 3 minus square root of 15. Sorry, plus square root of 15 minus square root of 15 minus 5. These cancel. 3 minus 5. Yeah, they're pretty much all the same. Simplify, obviously, here the technique is to understand that a fraction can have, so when he's saying simplify, we're expected to get rid of the square root of the bottom by using the techniques we just learned. Okay? And we're going to do it like this. So we can see at the bottom, you might be tempted to say, well, I want to get rid of the square root. 2. So I'm going to multiply by square root of 2 over 2 square root of 2. That's not going to do it. You have to treat this whole thing at the bracket as one thing. And that's why they were teaching you the thing before. So I know that if I multiply by the opposite sign, that square root is going to disappear. But I have to multiply the top by the same thing. Otherwise, the fraction would change. Here you get 5 times 5. And this is the bottom, 25. 5 times plus square root of 2 is 5 square root of 2. 5 minus square root of 2 times 5 is minus 5 square root of 2. So middle terms cancel. And minus 2. 25 minus 2 is 23. So down at the bottom, 23. In this, you have to treat this like a bracket, and you have to distribute 10 plus 2 square root of 2. You might be tempted to stop there. You could. 10 minus plus 2 square root of 2. However, you could technically factor out a 5, and you'd get 2. Sorry, not a 5, a 2. And you get 5 plus square root of 2. Then if this number down here was not 23, if it was something more interesting like 24, you could simplify this. This would become 1. This would become 12. But it isn't. It's 23. So it's just left like that. That's the simplified form. I'm going to do a couple other ones that maybe might be more difficult. So we're going to multiply by the opposite of this, top and bottom. What's the opposite sign? Plus. Plus. Treat the top like a bracket. 4 times 4, 16. Minus square root of 2 plus square root of 2, minus 2. So the bottom becomes 14. Up top, we distribute 5 times 4, 20. Plus 5 times square root of 2. You would not simplify the 5 into the 14 because it's not divisible. So yeah, you would just leave it like this. And forgive me for factoring out the 5 last question because it's essentially just return it to its state. Down below, let's see. I guess sometimes they're hard to see what to do. There we go. We'll try this one. Well, the opposite of this is simply changing the middle term only. Minus 2 times minus 2 plus 4. Minus 2 times plus square root of 2 is minus 2 square root of 2. Minus square root of 2 times minus 2 becomes plus square root of 2 times square root of 2, so the middle terms disappear. And minus square root of 2 times plus square root of 2 becomes minus 2. So you get 4 minus 2, which is 2. Up top, when I distribute, well, you know what? I'm not going to distribute yet. I'm going to leave it like the 4, and it's multiplying minus 2 plus square root of 2. And I say, you know what? This 4 can simplify with this 2, and it just becomes 2 up top. And the 2 down below becomes 1 or it disappears. And now I can distribute if my teacher wants me to. 2 times minus 2 is minus 4. And then plus 2 square root of 2. Let me just see if that's sort of what it's showing you the same thing there. And yeah, this answer is not correct. Because I think he made an error here. It should be minus 2. Oh, maybe not. Hang on, let me see what I got. No, I'm minus 4. 2 squared root 2. Yeah. It's the same technique over and over again. So that's that one. I'll do the other pages later.